Have you ever wondered how aircraft wheels work and why they are so important? In the realm of aviation, every component plays a crucial role, and aircraft wheels are no exception. These seemingly simple structures are essential parts of an aircraft's landing gear system, serving multiple critical functions during taxiing, takeoff, and landing. Their primary duty is to support the full weight of the aircraft while it's on the ground, and they do more than just carry this weight. They also transmit the static and dynamic loads generated during takeoff, taxiing, and landing into the aircraft's shock absorption system, usually an oleo-pneumatic shock absorber or a steel spring. But there's more to these wheels than meets the eye. As we delve into the world of aircraft wheels, we'll be exploring their design, construction, and maintenance. So buckle up and get ready for a fascinating journey into the world of aircraft wheels. So, what is the main purpose of aircraft wheels? Well, these vital components of an aircraft's landing gear system carry out several critical functions. The primary purpose of aircraft wheels is to support the full weight of the aircraft while it's on the ground. They also play an important role during taxiing, takeoff, and most importantly, landing. As an aircraft lands, the wheels transmit static and dynamic loads generated during these phases into the aircraft's shock absorption system. This shock absorption system typically consists of an oleo-pneumatic shock absorber or a steel spring. These components work in unison to ensure a smooth and safe landing, absorbing the impact and reducing the stress subjected to the aircraft's structure. However, it's essential to differentiate between the wheel and the tire. The wheel is a cylindrical metallic structure connected to the landing gear axle through bearings. It provides a seating surface for the tire. On the other hand, the tire, made primarily from rubber, is the only part of the aircraft that comes in direct contact with the ground. Aircraft wheels are typically made from lightweight and strong materials such as aluminum alloy. Some wheels also use magnesium alloy for its excellent strength-to-weight ratio. Unlike automotive wheels, which are usually single assemblies, aircraft wheels are constructed in two pieces. These two-piece wheels are then fastened together after the tire is installed. The two-piece construction is necessary because aircraft tires are designed to flex significantly to absorb large impact loads without separating from the rim. In the early days, two-piece wheels had a design similar to automotive tires. They featured a removable flange that allowed easy tire installation and inflation. The removable flange facilitated tire mounting onto the wheel, which could then be inflated to the desired pressure. The modern two-piece wheel is a more evolved design. The wheel is split into two nearly equal halves, bolted together with an O-ring in the center, forming a tight rim seal. The two flanges create the bead seating region, where the tire contacts the wheel. During touchdown, the tire compresses rapidly, exerting a large tensile load on the flanges, which are designed to withstand the loading and prevent tire slippage relative to the wheel during heavy braking. Clearly, the function of aircraft wheels extends far beyond what meets the eye. Before we move further, it's important to differentiate between the wheel and the tire. Let's start with the wheel. Picture a cylindrical metallic structure. This is connected to the landing gear axle through bearings and serves as a seating surface for the tire. Its robust structure is designed to withstand the immense pressure of an aircraft's weight and the dynamic loads during takeoff and landing. Now, think about the tire. It's primarily constructed from rubber and is the only part of the aircraft that comes in direct contact with the ground. The tire plays a significant role in absorbing ground impact and providing the necessary friction for braking and steering. So, in essence, the wheel is the metal structure that supports the tire, while the tire is the rubber component that interacts directly with the ground. Now that we've differentiated between the wheel and the tire, let's look at how wheels are constructed. Aircraft wheels are unique in their construction, especially when compared to automotive wheels. In the world of aviation, lightweight yet sturdy materials are essential. As such, aircraft wheels are typically made from an aluminum alloy, chosen for its strength and weight-saving properties. However, in some cases, you may find wheels constructed from a magnesium alloy, another lightweight yet robust material. Now, if we compare the construction of aircraft wheels to automotive wheels, we'll notice a significant difference. While car wheels are generally single assemblies, the construction of aircraft wheels is a bit more complex. They are made in two pieces, a design choice that is far from arbitrary. Why two pieces, you may ask? Well, this design is crucial for the function of the wheel and tire. Aircraft tires are designed to flex significantly to absorb the large impact loads that occur during landing. This flexing could potentially lead to the tire separating from the rim of a single-piece wheel. However, the two-piece design of aircraft wheels prevents this from happening. So, how does this work? The two pieces of the wheel are fastened together only after the tire has been installed. This assembly process ensures the tire is securely held in place, allowing it to flex without the risk of separation. But the construction doesn't stop there. Each half of the wheel is carefully designed and manufactured to ensure perfect alignment when they are joined together. This alignment is critical, as any misalignment could lead to uneven tire wear or even a potential tire failure. In essence, the two-piece construction of aircraft wheels is a perfect example of engineering brilliance. It showcases how a seemingly simple design change can significantly improve the safety and efficiency of an aircraft. This two-piece construction of aircraft wheels is fundamental to their function, but let's take a look at how this design has evolved over time. From removable flange wheels to modern two-piece wheels, the design of aircraft wheels has come a long way. In the early days of aviation, aircraft wheels were designed much like the wheels on your car, featuring a removable flange. This removable flange allowed for easy installation and inflation of the tire. However, as aircraft technology advanced, so did the design of wheels. The modern two-piece wheel, which is now the industry standard, is split into two nearly equal halves. These halves are bolted together, with a rubber O-ring nestled in the center to form a tight seal. This two-piece construction is crucial in allowing aircraft tires to flex significantly during landing, absorbing the immense impact loads without separating from the wheel's rim. Now let's talk about the bead seating region. This is the area where the tire comes into contact with the wheel, created by the two flanges on the wheel halves. During touchdown, the tire compresses rapidly, exerting a large tensile load on these flanges. But don't worry, these flanges are designed to withstand the load and prevent the tire from slipping relative to the wheel during heavy braking, a feature absolutely essential in keeping the aircraft under control during landing. This modern design is not just about safety, though. The two-piece construction also makes it easier to replace tires when they wear down or get damaged, thereby reducing the need for costly and time-consuming wheel replacements. As we've seen, the design of aircraft wheels has evolved significantly, from the simple removable flange wheels of yesteryears to the sophisticated two-piece wheels of today. But with this sophistication comes the increased need for regular inspection and maintenance to ensure these components continue to perform their crucial role safely and effectively. With the evolution of wheel design, the importance of inspection and maintenance has also grown. So, next time you board a flight, spare a thought for the humble wheel and the engineering marvel it represents. Just as with any other part of an aircraft, regular inspection and maintenance of wheels are crucial for safe operation. This is where we land on the final leg of our journey, delving into the world of aircraft wheel inspection and maintenance. The inspection and maintenance of aircraft wheels are often taken for granted, but they play a pivotal role in ensuring the safety of every flight. To keep these wheels in tip-top shape, there are a few key procedures that are followed. First off, nitrogen inflation is a common practice in aircraft tire maintenance. Unlike air, nitrogen is less likely to cause oxidation, which can lead to wheel corrosion and tire degradation. It also has a lower rate of thermal expansion, providing more stable tire pressure during flight operations. Next up, we have fusible plugs. These are safety devices installed in the wheel hub. In the event of an extreme rise in temperature, such as during an intense brake fire, these plugs melt and release the tire pressure. This controlled deflation prevents a tire burst, significantly reducing the risk of damage to the aircraft and its occupants. Lastly, let's talk about tire pressure monitoring systems, or TPMS. These systems continuously monitor the pressure in each tire and provide real-time data to the aircraft's cockpit. A sudden drop in tire pressure can be an early warning sign of a potential issue, such as a slow puncture, allowing the crew to take corrective action before it escalates into a more serious problem. It's worth noting that different aircraft models have varying wheel systems, each optimized for specific performance requirements. These systems are meticulously designed and rigorously tested to withstand the extreme conditions of aviation, from the heat of a desert runway to the cold of an Antarctic landing strip. So, the next time you see an airplane taxiing, takeoff, or landing, remember the crucial role played by these seemingly simple wheels.
Their intricate design, robust construction, and regular maintenance ensure safe landings and smooth taxiing for every flight.